Thank you so much for watching this online video tutorial. Like, comment, and share, as well as subscribe to our channel at Good Better Best Online Videos for more video content. Alright, ladies and gentlemen, alright, good afternoon or good evening formally. All of those will also be tuning into this video when it gets released. Hello to you guys as well. What we're going to have a look at today is the follow-on from last week's section, where we looked at the lithosphere as well as looking at the Earth's structure. Okay, we're going to move on to the rock cycle now. Okay, and which kind of also has to do a little bit with more into the Earth structure as well, that topic as well, before we move on to mining of mineral resources. Okay. So let's introduce the rock cycle first of all. Okay, there's different types of rocks though. We've got igneous rock, we've got sedimentary rocks, we've got metamorphic rocks, and also we're going to have a look at a little bit of volcanic process, because that's often how rocks are also formed sometimes, or it not sometimes, maybe sometimes is the right word, because volcanoes don't erupt on a daily basis or every day or frequently. They sometimes have times when they erupt, unless of course there are places on Earth where volcanoes do erupt frequently, like maybe once, twice a month or once a week. Not really sure. I've always known a volcano to be very unpredictable, of course. Okay, but when we think of rocks, okay, we find a lot of them on mountains, just by the way. And if you live in the surrounding areas here in the southern suburbs of Cape Town, you will see mountains. Well, you'll see the view of the mountain, Kirstenbosch, Table Mountain, etc. Klomp rocks there. Okay, we think of rocks as being strong, steady, and lasting forever. Okay, very hard substances. All right, not easy to break unless you're Superman. However, this is not entirely true. Okay. There is a very slow process going on in which rocks are made, then get broken down, and then get remade again. All right. So the rock cycle basically is a slow process. We can identify that it's a slow process. Okay. A couple of things happen. Okay. They are made, broken down, and then they're made again. Okay. We call this the rock cycle. Okay. That basically made, broke it down, made again is the rock cycle. However, this is not a quick process. This is not a 3-hour, this is not a 3-month or 3-year process. This can take millions of years. All right. It's a very, very slow process. In other words, the rocks that exist today didn't exist like way back in time. All right, most probably Cape Town looked a bit different. All right, mountains probably didn't look like it looked now. Okay, probably Table Mountain didn't even look like a table, right, for example. Okay, but during the rock cycle I mentioned, we get different types of rock. Okay, so let's look at the 3 types of rocks, okay, that I mentioned. Okay, 1, igneous rock. Okay, sedimentary, and the third one being metamorphic. Okay, metamorphic rocks. Okay, so let's first have a look at igneous. Okay, now igneous rock, probably one of my favorite rocks. Okay, because the word igneous is very closely linked to the word ignorant or ignoramus, like my dad used to call me when I was being foolish. Okay, but igneous rock has actually nothing to do with that. It's not a stupid rock. Okay, it's not an ignorant rock. It doesn't have a brain. Okay, so just to explain that quickly, let's just put a heading up for igneous rock. Okay, put a heading up for it quickly. Igneous rocks, first of all, they're rocks that have cooled, all right, from liquid magma. Okay, now where we find magma obviously in a volcano, okay, and lava or whatever comes up, and then of course when that magma that is now on top of the Earth's crust, all right, or on top of the Earth's surface, that obviously cools down, and when that cools down, igneous rock forms. Okay, let's just add that in here when it reaches the crust. Okay, we explained the crust last week with regards to the lithosphere. Okay, now what does igneous rocks contain? Okay, because they're coming from the depths of the earth, inside the earth, all right, it contains crystals, all right, that have a definite shape, all right, almost like sugar crystals, all right, which is what we, obviously sugar, by the way, the sugar that you put in your thing, they're called sugar crystals. Okay, cool. Now, of course, when it comes to let's put it this way, when they are cooled down, of course, you take pieces of them, you can clearly see the crystals that are very easily visible, all right, but of course they can obviously be broken down and crushed into finer pieces, all right, those crystals exactly, but obviously in bigger chunks, their crystals can actually be visibly and easily seen, all right. Usually what they do with igneous rock, they use a sugar cube model, all right. Now sugar cubes are basically cubes of sugar, all right. Almost instead of taking spoonfuls of sugar, you just take a sugar cube, which might be either a spoon or 2 spoons full of sugar. I've never seen it in South Africa, but I've seen it a lot in places like England or whatever. They do a lot of sugar cubes there for some reason. Don't know why. Okay, just take a spoonful of sugar. All right. Now, something we must say is that if igneous rock is, if the igneous rock cooled very quickly, then the crystals will be very small, right, and the rock will be smooth. Now, an example of under the sugar cube model, okay, is that if you take a look at icing sugar is basically a model of rapidly cooled igneous rock. All right. Now, rapid cooling. I mean, we're just comparing icing sugar to obviously igneous rock, the type of texture that icing sugar has, for example. But obviously, rapid cooling can happen if the magma comes to the surface, as what happens with volcano. Okay. If the magma reaches the surface of the earth, okay, and not the crust, all right. If it reaches the surface, of course, that rapid cooling can happen because obviously on top of the earth or on top of the earth's surface and not in the center of the earth, the temperature is much cooler. So of course, rapid cooling will happen. The magma will cool down quite fast. Okay, and that's about it with igneous rock. All right, so sedimentary rocks. First of all, they are rocks that have been made from small pieces. All right, they have been made from small pieces that have come off other rocks, and then they're carried away into rivers or by wind. Okay. Now, when these pieces collect somewhere, okay, we give them a name. They're called sediments. All right. So the definition for sediments is where these pieces of rock, all right, have collected in one spot or in a spot. Okay, it could be anywhere it could be anywhere. Okay, so let's have a look at an example. If we have an example of sediments that form at the mouth of rivers, all right. So this is common. Okay, that they form at the mouth of rivers because the rocks are carried in the water. And they also settle as the water slows down. So as the water slows down, the rocks obviously settle down also in the river. And obviously they will be collected there at the mouth of the river. All right. Now, just a little further explanation about this. Often they settle in different layers that give a banded appearance. So we should probably take a look at this in an image. So let's just go and see if we can find one and have a look at how that looks. So what we can see alongside here, okay, is that we've got this little collection here of all these little pieces they are now collecting. Okay, there's the mouth of the river. So this little these pieces here, this is called, okay, they've given it another name called sediment plume. But basically all these little images where the rocks look a little bit lighter or whatever, that's all sediments. Alright, they are collecting around a particular spot. Okay, sure, we can find another image of some sort to kind of see it a bit better. Okay, here's another one. Let's just open this up in a new tab so we can see it. Hopefully it's a nice big picture, not a small one. Alright, some more sediments also collecting here. Alright, just to get the picture in our mind of what a sediment or sediments collecting at the mouth of a river. Okay, that little banded appearance. Okay. Now after a long time, these sediments, they get squashed by other layers forming on top of them. And then they become, after a very long time, obviously of all this sediments collecting and whatever, alright, they become sedimentary rock, which often shows the layers from which it was made. This is a nice example of sedimentary rock. You can see the different layers here. Alright, there's rock upon rock there. You can see a layer there looking like that's a different type of rocks. In the middle here, there's the one that's got a more of a grayish in color. Look at this, the one that's got a little bit of a red line here, a little bit of a goldish yellowy. You know, and then you can see rocks on top. They all have one layer. They look like they collected over another layer here. So this has taken a while. All right, this has taken quite a long time to perfect. Or not to perfect, but to obviously form like this. So maybe we could say perfect as well. But you can see the type of, this is a lot of different rock that is made up here in this little mountain or gorge or whatever you want to call it. Let's have a look at some other examples. This is a piece of a rock, and you can definitely see, this image is clear enough to see the different types of colors and the different types of rocks that are made up here, as well as this piece as well. You can see the different, look at that black stone there. These black ones obviously different from the other white ones. So there's more than one kind of mineral in this little rock or piece of rock that's been broken off somewhere. Okay, so those are examples of sedimentary rock. I think we can also have a look at igneous rock maybe while we're here. Nothing wrong with having a look at some igneous. All right, obviously as a rock formed as a result of magma. All right, as you can see there's hot magma, but this would be an example of some igneous rock right there, where rocks coming up from the center of the earth, magma obviously reaching the crust. All right, and even reaching the surface of the earth, rapid cooling happen. This is rapid cooling happening right here. Another one over here is an example. They look almost like they've come out of space. Alright, metamorphic rocks. Okay, now first of all, these are rocks that have been altered by heat and pressure in the crust. Okay, that's a short enough definitions to remember, I think. Rocks that have been altered. So in other words, altered means they have been changed. The nature of the rock has been changed. Altered by heat and pressure. That's the ampersand for pressure. For and, sorry. Let's maybe not squeeze this word in here. Let's maybe write that a bit better. There we go. Heat and pressure in the crust of the earth. Okay. Now, both igneous rocks and sedimentary rocks, they can be changed into metamorphic rocks, and they can lose their characteristics if they get heated under pressure. Metamorphic rocks are often very hard. Okay, it's because we already have it there. I won't write it twice. They're often very hard. So they are often very, very hard rock. All right, is metamorphic rock. So just to have a look at some of the imagery around it. All right, let's have a look at this one. Metamorphic rocks. That's one. there's another one. Here's a whole list actually in this one. Okay, let's see if we can open it up in a better tab. Okay, there we go. Lots of different types of rocks here that have been metamorphosized. Some of them look like they were sedimentary before. They very, very hard rock. Let's check out this one actually. I saw National Geographic there, and I love National Geographic. Okay, it's pretty small, so we can't really see that. Very small image. But of course the list is obviously endless. I think this one is a igneous rock. I think that changed it to a metamorphic rock. I think this would be your igneous one. This would be your metamorphic. So yeah, that definitely looks much harder than that. Okay, so those are the three different types of rocks, okay, that do exist. Okay, we've looked at the igneous, sedimentary, metamorphic being the third one, but we found something new, is that igneous and sedimentary can evolve, or they can be altered into metamorphic rocks if they are under great pressure and are heated. Then they can obviously become metamorphic rocks, which are often very, very hard. Okay, now there is an actual step-by-step, about 11 steps of the rock cycle. Okay, so what we're going to do is, instead of putting that down, I'm just going to have a look at an image quickly and see how we can explain it. Okay, so let's go find an image of the rock cycle. Sorry, that's not supposed to be right there. There you go. The rock cycle. Okay, let's have a look at a rock cycle diagram, and let's just pull it up here quickly. This would probably be a good one. Like I said, there's 11 steps, so I just want to find one that is a little bit simple first, and then we'll explain it. So let's try this one. Open it up, or open the image in a new tab. Okay, I hope it hope the view changes, the quality of the image changes. Okay, no, it doesn't. So let's see what else we can find. Okay. Okay, I'll try one that maybe I saw here on top. Maybe that one I already tried. Let's try this one. See if this image is clear enough to open the image in a new tab. Okay, that's really, my luck is running out here a bit. Okay, let's take that one out. Okay, let's give this a go. Sorry, this is taking so long. Much better. Okay, cool. So we've got obviously the Earth's mantle. Okay, now it's a code red there because the magma from the mantle will push up into, or pushes up into the rocks of the crust. All right, it pushes up. Okay, so of course it's going to push up and go, and obviously it's going to follow this little trail and come back down and then go back in. Alright, it's going to do all that. Okay, so below the surface, the magma cools down quickly, sometimes taking millions of years to form igneous rock and large crystals. For example, granite. Okay, let's not have a look at that. If we have a look here, we've got the Earth's mantle and the metamorphic rocks that have suffered obviously heat and pressure, and they are now obviously changed into igneous, all right, and now melting process happen, and then of course that intrusive igneous rock now is going to get push up into the crust of the Earth and then possibly erupt or exit through a volcano. Okay, and sometimes magma that escapes to the surface will cool very quickly, all right, as a result of a volcanic eruption. All right, the rocks that will form will be slightly different. Okay, now if the rocks that come out of a volcano, which will be the extrusive, which means obviously exit, okay, exiting, okay. The cooled volcanic rocks are very smooth and they are different from other igneous rocks. Okay, there's a name for cooled volcanic rock. Okay, there's a name called for it. Okay, so add this in here. Cooled, smooth volcanic rock are called basalt. Okay, basalt. Okay. If there's a lot of gas in the magma that comes out of the volcano, because remember, lava or is not the only type of volcanic eruption, of course. There is hot ash that has also erupted. Okay, and gas, all right, poisonous gases. Then if that comes out of the volcano, it makes the smooth rock full of little holes, causing it to be very light in weight. Okay. Now, cooled, smooth volcanic rocks, all right, with little holes in them, all right, they are called pumice stone. Okay, so those quotes there are the same thing. Cooled, smooth volcanic rock with little holes in them as a result of the gases being released with the magma. All right, they obviously have a lighter weight, and they're called pumice stone. Okay, now the rocks on the surface, they are slowly worn away by heat and cold. All right, as in the diagram. All right, once they've exited here. Okay. By heat and cold, and by wind, rain, ice, so weathering. All right, and then of course because of this weathering, all right, that's happening, or this bit of erosion, all right, it's those rocks are broken up into smaller particles. Okay, because of all this weathering, because by rain, heat and cold, snow, ice, etc., depending, that's called weathering. Okay. Then the small particles that have come off the rocks by weathering, they carried away into rivers or by the wind, all right, into the ocean, floodplains, and obviously that word is called erosion because the rock has eroded away. Okay. Now, of course, they make layers of sediment, as we can see in the diagram. Okay, erosion, deposition, of course, they are deposited. Okay. Then there's some compaction with some little extra words here, deposition and compaction. And then you have sediment rock, right, or sedimentary rock. Okay, because all over time, those sediments, of course, they are covered by more and more layers. Okay, now the older sediments, they get pressed down because of more sediments coming on top. The older ones, they get pressed down. All right. Because of the weight of the new sediment that's on top. Now, because of that great pressure of the layers of the sediment, that changes the lower layers into sedimentary rock, of sedimentary rock into something called sandstone. Now, sandstone is obviously, it's in the name, right? Sandy stone, but obviously sand a little bit weaker, all right, than normal rock. The thick layers of the sedimentary rock, for example, if you look at if you ever hiked Lion's Head or Table Mountain, you'll see all those thick sediments of rock there that have like formed. If you take note of that, if you go on hikes and whatever, like I do, I love going on hikes and whatever. Okay, you'll see it took millions of years to obviously form. Okay, now just sticking back here. After we are by sedimentary rocks, okay, when the sedimentary or igneous rock is close to a region of hot magma, because remember now all that has been pushed down and pushed down and pushed down over time and over long periods of time, okay, it may be heated by the magma because magma is obviously very, very hot. And that heat changes the chemical structure to make something that's called metamorphic rock, all right? Cool. That sedimentary rock or igneous rock that's now been changed or heated by magma, all right? And then, of course, that melting process happens, all right? And boom, the rock cycle completes itself or starts over again, okay? But because of that sandstone, which is that soft sedimentary rock, we call that shale, all right? And when it'll often turn into a harder substance called slate because of the heat and pressure, okay? A similar sedimentary rock called limestone will turn very hard into a metamorphic rock called marble, all right? So if we have a look at a sedimentary rock, let's just add this maybe to our notes, okay? A type of sedimentary rock, all right, called limestone, okay? If it undergoes extreme heat, boom. If it undergoes extreme heat and pressure, okay, it'll evolve or change or be changed into into metamorphic rock called marble. So marble is the hardened or metamorphic rock version of the sedimentary rock called limestone.
JP.
And obviously at the end of that, when all that sedimentary or the igneous rock has become very close to the magma once again, if it sinks far enough, it will melt, of course, to become magma again, or to rise up again and turn into igneous rock, becoming very intrusive on the mouth of the volcano, and then obviously being exited, all right, or exiting the volcano, the mouth of the volcano, which is obviously from the center of the earth. And then this whole process will obviously continue itself again. Okay, but this is the rock cycle. Is exactly what happens. This picture is a little bit of a simplified diagram, obviously not so much words in it. Okay, but if you can understand this with these little keywords, then you know that you prepped for getting this question in the exam. You know, you prepped for it. You'll be able to explain exactly what happens. Okay, so the rock cycle basically start from here when obviously the magma rises, exits with the erosion and weathering, and the deposition, and obviously the compaction with all the layers and layers of sedimentary rock, of those broken particles of rock that are obviously forming on top in layers and layers and layers. And of course, as the layers get much, the top layers push down on the bottom layers, and if these layers at the bottom get close enough to the Earth's mantle or close enough to the magma in the Earth, it will obviously heat up, and then the rock cycle will start from scratch again. And this process does take a long time to obviously form. Thank you, grade 9s, for joining me this evening on the rock cycle. All right. Next week, we're going to move on to mining of mineral resources. Okay. We're actually taking the minerals and that are found obviously in the crust, or just further down in the lithosphere, taking some of those minerals out and looking at how that process is. All right. Please don't forget to like and subscribe to our channel, as well as comment on this video if you enjoyed it, as well as subscribe to our channel, which is Good, Better, Best Online Videos. I will catch you in the next one.